The first law of thermodynamics can most easily be expressed through an equation. In this equation, Q is the heat, W is the work, and delta U is the change in internal energy. So the total heat transferred is equal to the work plus the change in internal energy of the system. When dealing with these values, we want to be careful about when they are positive, when they are negative, or when they could possibly be zero. So we'll go into that in a bit more detail. For one thing, the heat is positive when heat is added, and therefore heat is negative if heat is removed. But remember, this Q refers to as the total heat transferred. So if heat is both added or removed, we find our Q, our total heat transferred, by subtracting the heat removed from the heat added. Now the reason they use the values or the letters H and C is because heat is added if we touch it to a hotter reservoir. So that's why QH is heat added. And heat is removed if we touch it to a colder reservoir. So that's why QC is the heat removed. Now the heat may be zero if it's an adiabatic process, which means that it's a rapid expansion or compression of our gas in this case, or our fluid. Work is positive if work is done by the gas, and that means that it's going to expand. The volume will increase. Work is negative if work is done on the gas or on the system, and that's going to happen when it's compressed or the volume is decreased. So we want to watch out for these keywords by or on. They will tell us whether or not the work is positive or negative. Work is zero if it's an isovolumetric process or an isochoric process, as it might more oftentimes be referred to as. This means that there's no change in volume, and that'll occur if we're in a rigid container. So we want to watch out if it says a rigid container. For the change in internal energy, that's directly proportional to the temperature. So if the temperature increases, the internal energy will increase as well. If the temperature decreases, that means that the internal energy will decrease as well, so it would be negative. There is no change in internal energy if there is no temperature change. This means it's an isothermal process. We might also have no overall change in internal energy if it's a cyclic process. So if ever you see anything about being cyclic, that means that the internal energy might go up at certain points, might come down at certain points, but the overall change is zero. So it goes up and down by the same amounts, and we end up with the same amount of internal energy in which we started. So the overall change is zero if we see it's a cyclic process. So again, the first law of thermodynamics says that the total heat transferred is equal to the work done on or by the system plus the change in internal energy of the system. We just want to watch out when they're positive, negative, or zero.